Namaste everyone, my name is Srikanth and in this video we'll be taking up this particular problem which appeared for OU students this year. So you can see two blocks have been given to us, one block being 400 newtons, the other being 300 newtons. They are connected by a cord like this passing over a frictionless pulley, and a force of P has been applied at an angle alpha on the 300 newton block, and we have been asked to find out the minimum force P that will cause the motion of these blocks to move towards right. And the friction between the two blocks has been given as 0.3, so mu value has been given as 0.3. So let's go ahead and solve this. So first we'll have to draw a free body diagram of this block over here. Now the forces acting on this block are this force, which is the tension in the thread. Then a force of 400 newtons will be acting straight down. Then there will be a force which will act perpendicular to the surface here, and that is the normal reaction. And because the tending motion is towards the right side, there will be a force acting towards left, and this will be the force of friction, that being mu times n. Now the mu value has been given to us here, so we'll just put that value directly, and that is 0.3 times n. So that's it. These are the forces acting. Now let us take the two axes as x and y axis. The axis which is parallel to the surface, we will take it as x, and the axis which is perpendicular to it, we will be taking it as y. Now this angle here will be same as the angle made by this with the horizontal, and that being 40 degrees. Now we have to take the two possible equations of equilibrium, the sigma h and sigma v, both being equal to 0. Now there are only two unknowns in this, and both these unknowns can be solved by using these two equations. So let's go ahead and use them. Let's first take the horizontal. Actually it's not horizontal because this is inclined. So instead of horizontal, we'll just have to take it in x direction, and this one will be in y direction. Now let's take all the components which are acting in x direction. T being in positive x direction, we have to take it as positive, and 0.3 newtons being in opposite to it, we'll have to take it this way. Then the component of 400 newtons will also be acting in negative x direction, so we have to take it as minus 400, and the component itself will be sine of 40. The total of course has to be equal to 0. Now let's just rearrange the terms so that we get the equation in proper format. So this will become our equation number 1. Now let's take up all the vertical components. N is acting in positive y direction, so it's got to be positive. Then in the negative direction, we have a component of 400 newtons, that component being 400 cos 40. If you want to know in more detail how we take cos and sine, there is another video which I have made. I'll leave the link in the description below. You can check it out to understand how I am taking it. Next, there are no other components in y direction, so the total has to be equal to 0. So we will be able to find the value of n here. I'll just use the calculator. Okay, so that's 400 times 40 cos. So this gives me 306.42. So 306.42 is the value of n. Now this value, if we substitute in the equation number 1, we will get the value of tension T. Let me take the same equation once again, and now let me substitute the value of n over here and calculate it. Okay, so I'll just first calculate 400 times 40, that is sine, and 0.3 n also have to send it to the right side, it becomes positive, that's plus 0.3 times n value being 306.42. so this is the total value, 349.04. so 349.04. so this is the value of tension that is acting in the string. Now this tension, because it is passing over a frictionless pulley, pulley, the same tension will be acting on this side as well. Okay. So now we will have to take a free body diagram of this block. Okay, so let me take the free body diagram of this block over here and start putting all the forces on it. So there is a weight that's acting downwards, that being 300 newtons. Of course, there will be a normal reaction at the surface. Let us call it as M. Friction will be acting on the left side because the object itself is trying to move towards the right. So this will be 0.3 times M. And of course, the tension T, which is acting on the string, will be same as what we found in the previous step. Now let's go ahead, take this free body diagram, and once again we'll have to decide the two axes, the vertical one and the horizontal one. So this is the horizontal one, this is the vertical one. You can also continue to call it as X and Y, that is not a problem. It's just that I'm more comfortable using H and V, horizontal and vertical, wherever it's possible. So let me just go ahead and take vertical components of all the forces. There is a force M that is acting exactly in the positive vertical direction. Then there is a component of P which is acting in vertically upward direction. So that as well I have to call it as positive. And that is P sine alpha. Then there is no other component which is acting in the vertical direction. So this total has got to be equal to 0. Oh, sorry, I forgot to take one particular force, and that is the weight itself. So minus 300 newtons. So this is the force that is acting downwards, hence got to be taken as negative. Let me just remove this value of n because this is just for the that will confuse us with some alphabet because we are using n over here. So let's just forget it. Now we can observe here that there are a lot of unknowns. M is unknown, P is unknown, alpha is unknown. So many unknowns, we cannot find it using just a single equation. So let us just give it an equation number, that is 2, and go to the next one. Now let us take the horizontal components. T is acting in negative direction, so minus T, and 0.3 m is the friction force that is also acting on the left side, hence I'm taking it as positive. Then the horizontal component of P, that is P cos alpha, this one is acting on the right side, hence I have to take it as positive, and this total has to be equal to 0. Now here once again we are getting 3 unknowns in all. Tension value, of course, we know it from the previous calculation. M, P and alpha are the 3 unknowns. So we'll just have to use substitution method to reduce these equations. So what I'll do is I'll take another step over here. M equals, that is 300 minus P sine alpha. So I'll call this as the equation 2 instead of the upper one. And now I'll just substitute this M over here. So let me substitute the tension value, that is 349, of course, minus 349.04 minus 0.3 times this complete value I'll have to take here. So that comes over here. And then I'll have to continue adding P cos alpha. So this total has to be, of course, equal to 0. Let's go ahead and simplify this equation. Negative values, the constants, let us send to the other side. So what happens is this 349.04 on the other side becomes positive, and this negative 0.3 into 300 will also become positive on the other side. What's remaining on the left side here is 0.3 times P sine alpha. We'll just take P common over here. So 0.3 times sine alpha will remain inside, plus cos alpha will also remain on the inside. Let us now do the calculation for this part. That is 349.04 plus 0.3 times 300. So that gives us 439.04. 439.04. Now let's send this term as well over to the other side. So it comes here below this, and this will be equal to the value of p. So now, since we have to find the minimum value of p, and over the graph, we have to use the condition for maxima and minima. So for that, basically what we have to do is differentiate the value of p for which we want to find the minima with respect to the other variable, that is alpha. So dp by d alpha, and you have to find this equation, and the equation itself we will have to equate to 0. So let's go ahead and differentiate this. So dp by dx, we will have to differentiate. This value 439.04 being constant will not be affected. This value, this whole value below, we will have to use it as 1 by x, and we all know the differentiation of 1 by x is 1 by minus 1 by x square. So this value will come here, square minus, fine. So minus 1 by x square into, now we have to apply the chain rule. So what happens is 0.3 times differentiation of sine alpha, that is cos alpha, and plus, okay, sorry, this is going to be minus, because differentiation of cos alpha will be minus sine alpha. So this is what we are getting. So this total, we'll have to actually equate it to 0. We have to equate it to 0. So now what happens is, when we send the denominator to the other side, this gets completely cancelled, and we are just left with a value in the numerator. So this value is equal to 0. The constant value also get cancelled, and when we send it to the other side, so basically what we get here is 0.3 times cos alpha equals sine alpha. So sending cos alpha to the other side, we get cos alpha over here. This is getting cancelled. So we get tan alpha, sine by cos by tan alpha equals 0.3. So now by just using the calculator, I can find out what is the angle alpha. That is 0.3 inverse of tan, that gives us 16.7. So alpha is 16.7 degrees. So this is the angle at which we have to apply the force P, so as to get its value as minimum. Now substituting back this value over in this equation, we will get what is the minimum value of P, and let's go ahead and do that. So 439.04, this has to be divided by a long value. I'll just put a bracket here. 0.3 times alpha being 16.7, sine of this, 0.3 times sine of 16.7 plus cos of the angle, so 16.7 cos of this angle. Now let me close the bracket, find the total value. So we are getting 420.52. 420.52 newtons. So this here, what we got is the final answer to our problem. So the minimum force that we have to apply in order for the complete set of connected blocks, both the blocks, to move towards right is 420.52. Fine. You can apply the force at any, you can calculate the force at any other angle except for 16.7 degrees, and we will also always end up getting the p value as more than 420.52. So that's it for this particular video. Hope you have enjoyed watching this. Hope you have learned how to solve these kind of problems. More problems are coming up from previous university papers from various different universities. If you want your own university paper to be solved in one of these videos, you can just share it to me using the comments page here, and I'll definitely try to solve it out. Thank you for watching once again, and goodbye.